Hello and welcome to another video of the Unknown IITians channel. And I hope your quiz one went well. And now we are moving on to week 5, that is list and its functions. So the topics we are doing is introduction to collection and list data structure, pseudocode for list, basic list operation, list construction and operation, and list of pairs and list of triples. Right? So first is introduction to collections. So what is a collection? It is used to store collections of data. So, one collections you have already done is the set. So, what is a set? When you did set in mathematics, you usually did something like a set, a group of people who are participating in a particular sport, or a group of people who have taken mathematics as a subject. So, something like that. So, it was a collection of people, right? So, there are different types of collections, and set is one of them. So you have done set in mathematics, and now we are doing another type of set, another type of collection, that is list, tuples, and dictionaries. So what is a list? Suppose when you're making a list of groceries you need to buy, so you list out the types of groceries you need, right? So list is something similar when we do it in pseudocodes. The thing is, the lists that we use are ordered. So the difference between a set and a list is lists are ordered, right? So when we take a set, it's just a group of people. You do not care about the order in that case. But when we are dealing with list, we care about order, and a list is changeable. That is, you can make changes in the list further. You can edit the list further when you're going through the pseudocode, and it also allows duplicate numbers. So something like it can also take different types of values. So it can take like a string value, and then it can take an integer like something like 2, and then it can take boolean like true or false, and then it can take the same value again. Then suppose it took true as here, true as a value here, then it can take true as a value again. So it allows duplicate members. And the only difference between a list and a tuple is tuples are unchangeable. So once you have decided what your tuple is going to be like at the start of the execution of your code, you cannot make changes to it further, unlike list. So the values in the tuples are fixed, right? And set, as I told you, it's unordered. The order doesn't matter, and unindexed. So there is no indexing in the set, but as of lists, tuples, and dictionaries, there is indexing. So since the order matters, obviously there's indexing. So like the indexing as in the first value, the second value, the third value. So that is something like indexing. So the index doesn't matter in set because it's not ordered. And it also doesn't allow duplicate members. But as of list and tuples, there can be duplicate members. But in set, every person you're taking in a set is distinct when you're making a set of people in a particular subject. So every person is distinct. So there is no duplicate members into that are included into the set. And dictionary is also similar. There's no duplicate members in the dictionary as well. And it is also unordered. The order doesn't matter. And it is also changeable. That is, you can edit it later. The difference is in dictionaries, there's a key and then there's a value, then again a key, and then there's a value. So suppose in set it was just a group of people. So when we took the set, we only took either the roll number or something like that. But in dictionary, the key is something unique. Key cannot be duplicated. It's always a unique value. So as of students, the unique value is their roll number. Roll number is unique for every student. So the key is usually like the roll number for the student or the serial number or something like that. And the name of the student is then the value. Then again a second roll number when it comes to another student. And then again the name. So that is for dictionary. And right now we are not focusing on tuples, dictionaries or anything. We are just doing list in this video. So let's focus on list. So the pseudocode for list is, first there's a sequence within square brackets. So whenever you're dealing with list, you use square brackets. That is like a universal rule. So here we have used strings as integers as the values in the list, And here we have used strings. So you notice the difference is when we use string, we use a double comma or even a single thing. So when you do integer, you don't need to use these. You only do it when you're using strings. And empty list is just a square bracket. So like the length of empty list is 0. There's no element in the empty list. And how do you append to list? So to append the list, you always use the double plus operator. You cannot use single plus as that is used for adding integer values. So for appending, you use the double plus, right? So suppose there's list 1, that is 113, and then there's list 2, that is 271. So when you append it, you write the first list first, like the values inside the first list first, and then the values inside the second list. So suppose there were two similar lists. So suppose there's a list 1, 2, and 3, and there's another list that is 2, 3, right? So when you do list 1 plus list 2, so the new list will be 1, 2, 3, and then we'll add the duplicate values as well because list allows duplicates, right? So this will be 2, 3. So the first list first, then the second list. So there will be comma after everything, every value. So that is for appending, and for extending, that is we are extending a list L here with an item X. So we've used X in square bracket here. So this is similar to adding or appending a list of one value, appending a list with one item. So suppose there's a list that is 1, 2, 3, and then we use plus X. So the new list becomes 1, 2, 3, and X. 1, comma 2, comma 3, comma X. So appending is just adding one element to the list. So whenever you use whenever you have to add one element, you always use it in square brackets. That is, you make it a list, turn it into a list, and then extend the current list with the element you want to add into it. So then we move on to processing list. Typically, we need to iterate over a list, examine each item, process it appropriately. So we use for each operator for processing the list, that is for each x in L. So how does it work? The for each operator, so for each goes through each element in the list, that is iterates through each element in the list, and then it does something with the element, right? So it has to iterate. So suppose here, like it said, for each x in L. So suppose list L is 1, 2, 3. Then the first value of x, when we iterate through this list, the first value of x will become 1, and then it's going to do something with 1 here. Then the second value will become 2, then it's going to do something with 2. And the third value is 3, then it's going to do the same thing with 3. So that is how we iterate through each element in the list. So x iterates through value in the list L. Then for example, there's an example pseudocode here. We are checking for all students born in May who are also from Chennai. So let's see, there's a May Chennai list, which is an empty list first. Then there's already a May list present and already a Chennai list present. So it goes through for each x, that is for each element in the May list, and then for each element in the Chennai list. What it's doing, it's comparing both the elements from each other. That is, it's comparing the first student who was born in May to the first student who is from Chennai, and then it's checking if the same student. So if it's the same student, then obviously that particular student is then that particular student satisfies this condition, right? So it goes through each element in the May list using for each operator, then each element in the Chennai list using for each operator, and then it uses if condition to check if it's equal, and if it is equal, then it's gonna append this element into this list here. So um, so you remember this plus plus is used for appending. So every time there's a similar element, we're gonna append it into this list, and at the end we get people who are born in May and are also from Chindi. So let's see an example question. What will be the value of C at the end of the following pseudocode? So first we have a list A, that is 1 2 3 4 5, and list B is 1 2 3 4 5. So C is simply appending list A plus B. So when we append, I told you we write the elements of the first list first and then the elements of the second list. So let's see the options. So here they are adding up the values. We do not have to add the values, we have to append the list, right? So this is wrong. And then here they have done 1 2 3 4 5, and then they have reversed the list B, that is 5 4 3 2 1. So this part is wrong because we have to append the values as it is, not reverse it in any way. And then this is 1 2 3 4 5 and 1 2 3 4 5. So this option is correct. And then the plus plus operation is invalid. This is also wrong. We only use plus plus operation when we have to append the list. Then next, the following pseudocode is executed on the scores table. What will list L represent at the end of the execution? So first, list L is an empty list, and then we'll append the values later, right? So that's why we take empty list first. Then while table 1 has more rows, read first row X in table 1. Then they're checking if X mathematics is equal to X physics. So we are comparing the marks, the scores for mathematics and physics for a particular person, and if the values are same, then the chemistry marks of that person gets appended into list. So what are we adding into the list? The chemistry marks. Whose chemistry marks? People who have same marks in mathematics and physics. Right? So let's go through the options. It shows the chemistry marks of all the students. Not all the students. We are only checking for people who have same marks in physics and mathematics both. Then next, it shows the chemistry marks for all students who have scored same marks in both physics and chemistry. Not physics and chemistry. There has to be same marks in physics and mathematics. Then it shows chemistry marks of all the students who have scored same marks in both physics and mathematics. So this is correct. Because they're adding chemistry marks into the list and they're checking if both physics and mathematics have the same marks. Then it shows the names of all the students. This will be wrong because we're not storing names of students, we're storing the chemistry marks of students. Then the above code has an error, so the code doesn't have an error, so this is wrong. Then there's list indexing. So suppose there's a list that is 1, 2 and ABC here. So how do we index the list? The first element, that is 1, the index for this is 0. So this is the 0th element, right? And the second element is 1. So we do not start the indexing from 1, 2, 3, 4. We start it from 0. So it's not like first, second, third. It's like 0th element, then first element, then second element, the third element, and so on. So this is the second element, this is the third element, this is the fourth element. And then when the index of list is 0, then the value that it returns is 1 because the 0th element here is 1. Then when the index is 2, then what will it return? So this is the 0th element, this is first, this is index 2, so it will return this value, that is A. And we can also write it in this way, that is L0 equal to 1. So L is for the list L, that is list L here, and then 0 is the index, that is the 0th element, and this returns 1, that is the value present on the 0th position. So similarly for L1 it returns 2, for L2 it returns A, for L3 it returns B, for L4 it returns C. So this in the bracket here is the index. Okay, so that is how indexing of a list works. Then what will be the value of C at the end of the execution of the pseudocode? So we have list A and B here. Then we have taken the index A as 0. So 0 as in the 0th element, that is 1 here. So this will be 1. And then C is an empty list for each x in A. So for each goes through each element in the list A, iterates through each element in the list A. So we have initialized the index of B as 0 as well. So at 0 index, the value present is 1. So this is also 1. For each y in B, then we are checking if index of A is equals to index of B. So first, the index of both the values are equal. So index of A is 0 and the 0th element is 1. And the index of B is 0. So the 0th element is 1. So both the indices are equal. So then we are adding the values of x plus y into this z. So z is equals to x plus y. So what is x plus y? 1 plus 1, that is 2. Then we are adding the value 2 into the C list. So appending the value 2 into the C list. So I'm writing the C list here. C is equals to the first value added here is 2, right? And then what we are doing, we are adding 1 to the index of B. And then also we are adding 1 to the index of A. So this is after the bracket closes. So first we're adding 1 to the index of B. So index of A remains 0. Index of B becomes 1. Index B is equals to 1 in the second part of the iteration. And then we are checking if index of A is equals to index of B again. So the index of A is 0 and the index of B is 1. So this if operation becomes false and this doesn't iterate further. And similarly, it gets added, plus 1 gets added in each iteration. So as it iterates through the code, index B becomes 2. Then again this if operation fails, then again this becomes 3. Then if operation fails again until we go back to this part of the code. We go back to this part of the code, that is index of A increments. So index A becomes 1 in the next operation and index B goes back to 0. Then it's going to compare the indices again. So the indices are not equal again. So the B will be incremented again, right? So right now the indices of both the values are equal. Index of A is 1, index of B is 1. So then again it's going to do the x plus y thing, and x plus y for the index 1 present here is 2 plus 2. So 2 plus 2, that will be 4, and this z value gets appended to C. So now C becomes 2 plus 4. Similarly, as the code runs, it's gonna add each value present on the same index. So first it added the 0th and 0th value when we got 2. Then it added the first and first value, we got 4. Then it's gonna add the second and second value. So 3 plus 3, we're gonna get 6. Then it's gonna add the next value, that is the value on the third index. So 4 plus 4 is 8. Then 5 plus 5 is 10. So we get C list as this list. So the value would be this. This is the correct option. So there's an example here, identifying top students. So we have to find students who are doing well in all the subjects. That is, they are among the top 3 marks in each subject. Right. So we have a procedure for this. And how are we gonna do this? Using list. So we have to construct a list of top students in each subject and then identify students who are present in all the 3 lists. So let's say we have maths, physics, and chemistry, and then we have list for all the 3. So you have to find the first student, second student, third student, and we do the same for physics and chemistry. And then to find the top student, we have to find students who are common in both these lists. So let's say there's one student who is like first in maths, second in physics, and then first in chemistry, or there's a student who is third in maths, third in physics, and second in chemistry. So we have to find such students whose names are common in all the 3 lists. right? So we have a procedure for that. So let's see how this works. So first we are making a list of students who have like the first, second and third highest marks. So we initialize max, second max and third max to find the highest. And then while table 1 has more rows, read first row x from table 1. If x subject greater than max, then third max becomes second max. So this was like we did before. So there's a max, second max and third max. So if the x of a particular subject has marks greater than the first max, then this person's marks becomes the maximum marks, and then the third max, the second max marks goes into third max, this max marks goes into second max. So third max becomes the previous second max marks, the previous max marks becomes the second max marks, and the x subject becomes the max marks. So this is a procedure, right, for a particular subject. So here we can feed in the maths marks, we can feed in the physics marks, and we can feed in the chemistry marks, and we'll find the highest marks in the three highest marks in all these three subjects. So then if max we have the same procedure. So this was if the marks of x is greater than the maximum marks. But what if the marks of x is less than the maximum marks and greater than the second max marks? So in that case, the marks of x goes here, the second marks goes here, and the first max remains the same. So the third max becomes the previous second max, and the second max becomes the X subject marks of X student, right? The current student. So there could be another case where the marks of the X student is less than the second max, but greater than the third max. In that case, the marks of this student becomes the third max mark, and these two remain same, right? So the third max becomes the marks of X subject, and nothing else changes. So this procedure here gets followed for each of those three subjects, and at the end we get all the three lists for all the three subjects. And now we have to find the highest. We have to find the common between all the three lists. No. So first we find the highest in all the three subjects. Right now we have to construct a list out of it. Here we find the highest, first, second, and third max. Now we are constructing a list out of it. So for the cutoff for maths is top 3 maths marks, top 3 marks when mathematics marks is used as a parameter. Then we do the same for physics and chemistry. Then we initialize all the three lists to empty lists so we can append all the marks later. So how do we append the marks? We use the pseudocode. So while table 1 has more rows, read first row x in table 1 if x mathematics is greater than cutoff marks. So whatever the cutoff marks is, if the marks of this student, if the marks of this student falls into this three marks, that is the top three marks, then the sequence number or the ID of this particular person, as in the roll number or whatever this particular person has, that ID gets appended into the list. Like in the first part of the pseudocode, we only found out the highest three marks, right? Now we are making a list of people who have the highest three marks. So we are writing the IDs of the people. So then the ID of the person gets appended in the maths list. And then we do the same if the physics marks is greater than the cutoff, then the ID gets appended. And then we do the same for chemistry too. So at the end, these three lists will contain IDs of people who have marks that fall into the range of the first three top marks, uh, who have top three marks in these subjects. And then we have to find the overall topper. That is, we have to find the a common ID between all these three lists. So we compare all the lists with the other lists. So we have the maths physics list, which stores the common elements present both in maths and physics. So first we are finding students who are toppers in both maths and physics, and then we match the stoppers with the chemistry marks. So we made a math physics list. So for each x in math list and for each y in math physics list, if x is equals to y, then we append the ID of this person in the math physics list. So what are these comparing? The IDs of the students, right? And then again we make a list of math, physics, chemistry, and then for each x in this list that we made here, we take the x and put it in here. So for each x in this list and for each y in chemistry list, we compare. If x is equals to y, then the ID of this person gets appended in this list. And then at the end, what will the math, physics, chemistry list contain? That is the IDs of people who have scored the top 3 marks in either in all of the 3 subjects. Right? So that was it. Now we have a question. Let list 1, list 2, list 3, list 4 be 4 non-empty lists. We wish to find the list of elements that are common among all the 4 lists. So select the correct code fragment that does this. So we have a procedure. That is, we take A list and B list, and then we initialize a C list. So for each element in A list and for each element in B list, if A is equals to B, then the element gets incremented, the element gets appended in the C list. And then the procedure returns the C list. So basically, we have to go through the options and see which is the right option. So list 1, 2 is the intersection between list 1 and 2. So here we are finding the common element in both the list, right? So this contains the common element in both lists. And what is a common element? That is the intersection in both lists, right? Like while you do sets, the intersection of 2 sets is the common elements present in both the sets. So that similar thing is done here in this procedure. So for list 1, 2, the list 1, 2 will contain the intersection between list 1 and 2. So this is correct. And list 3, 4 will contain the intersection between 3 and 4. And 1, 2, 3, 4 will be the intersection between list 1, 2 and list 3, 4. So like let's say there's a list 1, list 2, 1, 2. So this part here is 1, 2. And then there's a list 3 and then there's a list 4. So this is 3, this is 4. So this part, the intersection between 3, 4 is list 3, 4. And this small part here, that is the intersection between all the 4 sets, that is list 1, 2, 3, 4. Right? So this option is also correct. So this option becomes correct. And then we have list 1, 3 intersection between list 1 and 3. This is correct. List 2, 4 is intersection between 2 and 4. List 1, 2, 3, 4 is intersection between 1, 3 and 2, 4. So whether we take the intersection between, we could take the intersection 1, 2 and 3, 4, and then we can take the intersection between these two, or we can take this intersection, that is 1, 3, and this intersection, that is 2, 4, and then we can find the common part. So both mean the same thing, right? So this is also correct. Then we have another option. This option is correct. Then we have another option. List 1, 2 is intersection between 1 and 2. 2, 3 is between 2 and 3. 1, 2, 3, 4 is between 1, 2 and 2, 3. So here the fourth list is like not included in the options here. So this is wrong. So this option overall becomes wrong. And then list 1, 2 is intersection between 1 and 2. List 1, 2, 3 is intersection between list 1, 2 and list 3. Correct. This is correct because this, let's say there's 1, 2 and 3. So this is 1, this is 2, this is 3. This is 1, 2, and the intersection between list 1, 2, that is this, and list 3 is this part, that is this is 1, 2, 3. So this is correct. And then 1, 2, 3, 4 is intersection between 1, 2, 3 and list 4. This is also correct. Next we have some list operations. So let L be a list. Length of L returns the number of elements in list L. For example, length 146 returns 3. So let's say we have a list that is let's say we have the same list, that is L is equals to list 1, 4, 6, and then we use a length operator, that is A is equals to length of L. Then what will A return? That would be, your answer should be 3 because the length of this list is 3. And then similarly, we have first of L, which returns the first element of L. So let's say A is equals to first of L. Then A will return 1 because the first element here is 1. And here the first is not the same as indexing. This is, if we go by the indexing, if we use the indexing criteria, then this is the zeroth element, this is the first element, this is the second element, right? But when we use this, we take the zeroth element as the first element. This indexing is just the position. So the position for this particular, the first element is 0. That is, when we use the first of L, we take the element present on the 0 position, on the 0 index. Okay, so rest of L returns a list after removing the first element L. So it will return everything, but it will exclude the first element. So in this list, rest of this returns 4, 6. So like A is the rest of L, then A will return a list of 4 and 6, a list of the remaining elements. And we have some more operations here. So length, like we saw, it returns the length of the list. First of L returns the first element. And similarly, last of L returns the last element. So let's say we have A is equals to last of L when L is 1, 4, 6. Should be 1. So then A would return 6 because that is the last element. And rest of L returns everything except first. So this will return a list of everything except first. Let me just remove this. And then init is the opposite of rest. So this will return a list of everything except the last element. So let's say we have A is equals to init L. Then what will A return? That is the list of everything except last. So a list of 1 and 4. Like when we use rest, it returned a list of 4 and 6, right? And then init returns a list of 1 and 4, that is excluding the last element. And member LE, this returns a boolean value. This actually checks if the member E is present in the list L. So let's say we use A is equals to member L, and then we're checking if the element 4 is present in the list. So then this will return true. This returns either true or false. And then let's say we are checking if member of list is 3, then this will return false because this returns a boolean value. Then we have a question: the following pseudocode is executed using the scores dataset. So pair list is an empty list while table 1 has more rows. Read first row. If X mathematics is greater than X physics, then pair list, we increment physics and mathematics list in the pair list. So here you see we have used double square brackets. That is, we made a list of lists. So what is a list of lists? So there's a outer list and it contains multiple inner lists. multiple smaller inner lists. So this could have multiple values 1, 2, 3, 4, 5, 6. So there's a list containing multiple lists inside it. So like in this example, the outer list would be a different list and the inner list will contain the mathematics and physics marks. So it would be something like outer list, then this is maths, physics of some student, then maths, physics of second student, then maths and physics of third student. And we are only doing this for students who have mathematics marks greater than the physics marks, right? Or else pair list is equals to pair list plus physics marks, physics comma mathematics. So we do this for mathematics marks when the mathematics is greater, and when the physics is greater, we add physics comma mathematics. So let's say for the first student, the mathematics marks is greater, and for the second student, the physics marks is greater. So this will be PM. And then for the third student, again the physics marks is greater. This will be PM again. So in this case, the mathematics is greater than physics, and in this case, the physics marks is greater than the mathematics marks. So then we have to see what will first of pair list represent at the end of the execution. So when we get the pair list, it will look something like this list, right? And then what happens when we use the first operation? So the first returns the first element. So what is the first element in this list? That is MP. I'm just taking like an example. This could be physics and maths also. So here that is MP, and they're using another first. So because this is a list of lists, we take the first element of this list, and when we use another first, we take the first element of the inner list. So that is mathematics in this case. But suppose the physics marks for the first student was greater, so this would return PM. So in that case, the first of this would be physics. So let's see the option. Mathematics marks of student in the first row of table 1. What's table 1? Okay, table 1 is the initial table that we took here. Table 1 has more rows. So this is wrong. Physics marks of the student in the first row, not the first row. You have to see which student has greater marks in physics. And then mathematics of student in first row of table 1 if mathematics marks of student is more than physics marks. So this is correct because that is what we are checking. Physics marks of student in first row if the physics marks is greater than the mathematics marks. So this is also correct. In case the mathematics marks is greater, then we get maths as the option. And in case the physics marks is greater, we get physics as the option. Then next, what will first of pair list represent at the end of the execution if mathematics and physics marks of the student in the first row are same? So let's see. So here we check if the maths marks is greater than physics marks, then maths physics gets appended, else physics maths gets appended. So when we use else, it also accounts for less than, and since we didn't use equal to in the first condition, so the this else condition also implies for equal to. So this will be maths marks, this will be physics marks. So this implies for both less than equal to physics. So if they are equal, then physics maths will be appended, and then the first of this will return the physics marks. So the answer should be physics marks. So mathematics marks no, physics marks of student. This is correct, but let's see the other options. Could be either mathematics or physics. No, could be either mathematics or physics marks of student in the last row of the table. No, this is correct. So let's move on. What will C represent at the end of the execution? So A is this list, B is the opposite of A, C is an empty list. For each x in A, for each y in B, x minus y is equals to 2. let's go through both the lists and let's compare all the elements and let's see what C becomes at the end. So first, for each x in A, so first we're taking 1, that is the first element of A, and then we're taking B, first element of B, that is 5, and then we have to do x minus 5, and then we have to check if x minus y is equals to 2. So 1 minus 5 is not equal to 2, and then we check with the second element, 1 minus 4 not equal to 2, 1 minus 3, this is minus 2, so not equal to 2. Then 1 minus 2 is also not equal to 2, 1 minus 1 is also not equal to 2. Then we go through the next element of the list A, that is 2. So 2 minus 5 wouldn't give 2, 2 minus 4 is also not 2, 2 minus 3 is also not 2, and so on. This will not give 2 at any point. So 3, when we go through the 3 part, 3 minus 5, 3 minus 4, 3 minus 3, 3 minus 2, 3 minus 1 will finally give 2. So this is correct. So then we append the x and y in the C list, right? So C is equals to x plus y. So this becomes a list which contains both x and y that gives a value of 2 when subtracted. So this will be 3 comma 1. That is 3 in the first list and 1 in the second list. Then let's go through all the rest of the stuff. So when we go through 4, 4 minus 5 doesn't give 2, 4 minus 4 doesn't give 2, 4 minus 3 doesn't give 2, 4 minus 2 doesn't give 2, 4 minus 2 gives 2. So 4 and 2 will again get appended, 4 comma 2. Then 4 minus 1 doesn't give 2. Then we go through 5 part, and 5 minus 5 doesn't give 2, 5 minus 4 doesn't give 2, and 5 minus 3 finally gives 2. So then 5 minus 3 will get appended here. So this will become our C list. So this is 3 comma 1, 4 comma 2, 5 comma 3. So this option is correct. So next, let L be a list as shown below and A is equal to F. So we already know that A is equal to F. Be a true statement. Then choose the correct option. So we have a list L here, and then we go through all the options to see which option is correct. So we have multiple operations performed on list L here. We'll go through them one by one. So first, the first step is to look at the innermost loop, the innermost operation. So that is the rest of L. So right now, L has like 4 elements. This is 1, this is 2, this is 3, this is 4. So we have 4 elements in L. And first we are performing this operation, that is rest of L. So rest is everything apart from the first element. So this list, this is the rest of L. Now we are checking the first element of the rest of L, that is the first element of this new list. So the first element is this list, this particular list. So we are iterating over this particular list now. Then we have to check the rest of this particular list. So the rest of this list is F comma Madurai. So only this part, only this part. And then we have to check the first of this list again. So the first of this list is just F. And we have to check if A is equals to F. So this is returning F. So this statement is correct. Now we move on to the next option because this is an MSQ. So we perform these operations similar way in this question, in this option as well. So first we check for the rest of L, that is everything except the first element. Then we check the first of this element. So the first item, first element of this list, this new list, then init of this new list. So init is everything except the last element. So we exclude the last element here. The last element is Madurai. So the new list is now 4 comma F, and now we want the last of this list. So last of this is again F. So this is also returning F. So this is true. Then next option, we want the last of L. So the last of L is just this list. Then we want the rest of this list. Rest is F comma Chennai. So this part. Then we want the first of this part. So the first is again F. This becomes F also. So this is true. Then next option. We want the last of L and the init of this. So this is last and the init is everything except the last element. So we exclude Chennai and then we left with this list, that is 10 comma F, and we want the last of this list. The last element is again F. So this is also F. So this is true. So all the four options are correct. The next question. What will be the value of ID list at the end of the execution of the following pseudocode? So we have the same list L as we saw above. These are the four elements here. Then ID list is an empty list. So while length of L is greater than 1. So we have to find ID list, right? So let's make the ID list as we iterate through the list. So what is length of L now? That is 4. Since it has 4 elements, so 4 is greater than 1. And X is the first of L. So this is X right now. And then M is rest of L. So everything except first. So this part is M. And then while length of M is greater than 0. So M now has 3 elements. So 3 is greater than 0. Y is the first of M. So this particular element is Y. And if last of X is not equal to last of Y. So the last of X here is Chennai and the last of Y is Madurai. So this statement becomes true. And there's another statement, if first of rest of X. So let's see what's first of rest of X. So the rest of X here we know is everything except the first element. So this is M comma Chennai. So this list is M comma Chennai. I'm not using the commas here. So we want the first of this particular list. So this is M. Sorry, this is M. And then we have to check last. That is this part, last of init of Y. So what is that? Init of Y is everything except the last element. So this is 4 comma F and the last of this is F. So this is F. And then we have to check these two. These two are not equal. So we know M is not equal to F. This statement is true. So this particular statement also becomes true. And since we have an AND operator here, we want both the statements to be true. So these are true in that case. So we move on to this part, that is ID list plus plus first element comma first element of Y, first of X comma first of Y. So we make our ID list here. So it is a list of lists. So the first list contains the first of X, that is 2, and the first of Y, that is 4. So this is the first element of ID list. And then M becomes the rest of M. So M, our new M is this part. And then we go through this entire code again with the new M. That is this bracket closes here, right? So we won't go to this part. We will finish this while loop, this particular while loop here, because this condition still satisfies. 2 is still greater than 0. So we have to iterate through this list till M becomes less than 0, right? Till this statement becomes false. So 2 is greater than 0. Then Y becomes first of M. So this becomes our new Y. And then if last of X is not equal to last of Y, so Chennai is not equal to Bengaluru. So this statement is still true. And if first of rest of X is not equals to last of init of Y. So first of rest of X is still M because our X hasn't changed. And last of init of Y has changed. So we check this part. So Y init of Y is 11 comma M and last of this is M. So in this case, our statement was M, that is this part is not equal to this part, that is also M. So this statement is false right now. So this particular statement becomes false. And since we have the AND operator here, we cannot move any further, because if one of the statement becomes false, this entire thing becomes false. So we are not moving any further. We directly move to this part. We do not go inside the if bracket, if operator. So our new M again becomes the rest of M, that is just this part. So this is our new M, right? So right now the length of M is 1, and now Y is the first element of M, and since M just has one element, so that is our Y. So this is Y, element Y now. And then we go through this statement, these two sentences again. So we're checking the first sentence, last of X is not equal to last of Y. So last of X is Chennai, last of Y is also Chennai. So this first statement itself becomes false, and then we don't have to go any further. So because this becomes false, now M is rest of M. M becomes rest of M. So there's no more element left. Even if we do rest of this list, we're just left with like the Chennai. We cannot iterate over this again. So we go directly through to this part, that is L is equals to rest of L. So now L, this is L, but we want the rest of L, so we exclude the first part of this list, and now this is our new L. So L has 3 elements now, so 3 is still greater than 1. 3 is greater than 1. So we iterate through this again. So X is first of L, this is our new X, and M is the rest of X, this is M. Now we have to check, this is Y, this is our new Y. Now we have to check for the last of X is not equal to last of Y. So Madurai is not equal to Bengaluru. So this statement is true. And then we have to check for this statement. So first we check the first of rest of X. Since X has changed, this is also changed. So rest of X is right now F comma Madurai. And the first of this is F. So this becomes F. And last of init of y is the same because init of y is still 11 comma m. So the last of this is m. So this is m, and then we compare f with m. So f not equal to m statement is true. So this part of the statement becomes true. So in that case, we append the first elements of these two here in the ID list. So this 4 comma 11 will get appended here. So again we go through the list again. So M becomes rest of M. So M becomes this list again. This list is M, and this is also the new Y because Y is the first element of the list. Then we compare the last elements again. Madurai not equal to Chennai is true, and then X is the same. So this would be F. Then we check for the Y part. So init of Y is F 10 comma F, and last of this is F. So F not equal to F is this statement is false. So this part is false now. So we wouldn't go into this F statement, and we move directly into M is equals to rest of M. So there's nothing left to iterate over, no list to left iterate over in M. So we directly go to this outer part, that is L is equals to rest of L. So then again we remove the first part of L, we remove this part, and the rest of L becomes the new L. So this has two elements. So 2 is greater than 1, and now X is first of L, X, and this is M. This is also our Y again because it is the only element. And now we check the statements again. Last of X is not equal to last of Y. Bengaluru not equal to Chennai. This is true. then first of rest of x. So the first of rest of x again has changed. So what is the rest of x? That is m comma Bengaluru, and the first of this is m, and the init of in the last of init of y, this is the same again 10 comma f because y is the same. So this is 10 comma f and last is f, and now m is not equal to f. So this statement becomes true again. This statement is true. And this entire statement becomes true. So the IDs of these two will get appended in the ID list. So we append 11 comma 10 here. And this matches with the first option. There's no other option that is matching our thing. So I don't think we need to go any further. So this is our option. This is the correct answer. And I know these list operation are a bit complex now, but as you get a hang of it, you will be able to do the questions a bit faster with the list operations. So that's it for this video. Uh, Practice more and more questions using the list operation. So like you can get faster and you can maybe save some time in the exam. So I hope you understood the lecture and thanks for watching.